subscribe to our YouTube channel, Joy Learning TV.
Hello there, welcome to another session of Senior High School R on Joy Learning. I'm so excited to come your way with a physics lesson. My name is Anekwabi Albert. Most of my students call me Pius. So you call me Pius and we are good to go. Today, we are going to look at concept of matter for the Senior High School Form 2 level. And I believe I'm going to have a nice time. I'm going to understand things better, and you'll be able to go away with something that will give you a step further to achieving your A1 at the Senior High School Physics level. So we will start with matter. What is matter? This is something that we have known for some time now, right from the junior high school experience. And I am sure that you have the definition of matter in mind. We can say matter is anything that has mass. So we look at mass. We'll come back and look at what mass is. Anything that has mass and can occupy space. So we look at mass, we look at something that's got volume. It can occupy space. And then we say it exerts pressure and can be perceived by our senses. So matter should have mass. And then it should have volume. And then it should exert pressure. So mass, volume. We know that volume is the space occupied by matter. Mass, talking about the quantity of material an object or an object contains. So that its mass. It exerts pressure and can be perceived by our senses. So somebody could just say matter is anything that has mass and volume, and you are good to go. We want to look at the particulate nature of matter. When we say the particulate nature of matter, we mean the idea that matter is made of many tiny particles. Matter has many tiny particles, and these particles are atoms, molecules, and ions. So when you pick up a substance and we say this substance is matter, then we are saying that this substance is made of many tiny, maybe atoms, many tiny, maybe molecules, or many tiny ions, and they come together to make up that substance. Then we have what we call the kinetic theory of matter. The kinetic theory of matter. This theory tries to account for the changes we see in the physical and chemical properties of matter. So it happens that you have a substance, we call this is matter, then at a time there is a change in its physical properties. There's a change in its chemical properties. And so we try to look at why do we have this change. So it tries to tell us how come matter can be in different phases or different states. And then how come the molecules or the atoms or the ions can have different arrangements, and the result, the consequence of this arrangement on the material we're talking about. And so this theory tries to tell us why do we see different phases of matter in terms of differences in the arrangement of the molecules or the atoms that make up matter, and even differences in the movement of these molecules or these atoms. The kinetic theory has assumptions, and you would have to get to know these assumptions as we go along. One, it tells us that all matter is made of many tiny particles. So whatever we call matter has many tiny particles, and these particles are molecules. They are molecules. These particles are also atoms and ions. So I'm very sure your chemistry teachers will talk to you much more about molecules, atoms, and then ions. Then it goes ahead to say that the particles of matter are in constant, continual motion. So whatever state or phase of matter you have, its particles, whether it's made of atoms or molecules or ions, these particles are in continual motion. So they are just not static, they have some movements. The movements might not be visibly seen, but then you will know that there are some vibrations. Others too, you will see them vividly moving. Then we are saying that the movement of the particles increase with an increase in temperature. So as temperature increases, you will find out that the particles that make up this matter also increase in their movement. In that case, the energy possessed by a particle in motion is kinetic energy. So as the temperature increases, then it means that the kinetic energy of these particles will also increase. Then it goes ahead to tell us that as these particles move about, as temperature increases, they collide with one another. So there are collisions between the particles that make up matter. If there are molecules, there are collisions between the molecules. If there are ions, if there are atoms, they collide with one another. And these collisions are perfectly elastic collisions. So that gives us a throwback to our lessons in dynamics on collision. When we say the collision is perfectly elastic, in simple terms, we mean there is no loss in energy. There's no loss in energy during these collisions. So these are the assumptions of the kinetic theory of matter that you need to take note of. Matter is made of many tiny particles, and these many tiny particles are in continual motion, and their motion increases as temperature increases, and as they move about, they collide with one another, and these collisions are perfectly elastic collisions. No energy is lost. Then we are good to look at the phases of matter, which we can say the states of matter. And I'm very sure that you can recollect some very common ones like solids, like liquid, like gas. But we want to take a step ahead further and look at other ones that we have also come across. The list is not exhaustive though, but I'm going to look at about 5 phases of matter. And the first one is the Bose-Einstein condensates. Bose-Einstein condensates. We will take time and look at the properties or the characteristics of this phase of matter. Then we look at plasma. Then we come to the one that we are so familiar with, solid, liquid, and gas. So you have to keep them in mind. So you can write at least 4 of them. I know you know about 3 already, but you should be able to write about 4 of them by the end of the lesson. So we look at them again. We're saying Bose-Einstein condensates, then plasma, then we have our solid, our liquid, and our gas. Let's begin with the first one. Bose-Einstein condensates. Bose-Einstein condensates. What are they? Bose-Einstein condensates. We are saying it's basically very cold solid. Very cold solid. So when you talk about Bose-Einstein condensates, you are basically very cold solids. Very cold solids. That is it for you. And then they are only found at extremely cold temperatures. At extremely cold temperatures. And their particles are extremely close together. That should not be a wonder. They are found at extremely cold temperatures. that means that they will not really have so much energy for the particles to move apart or even do a lot of vibrations. So if you say they are extremely close together, that is one of the reasons for which it should be so, because of the cold temperature. And we are saying that because of that too, the particles barely move. So when we say barely move, I'm not saying that they don't move at all. It could be that the movement is quite negligible because they are so close together, and so they don't really have so much space to do a lot of movement. Then we are saying that amongst all the 5 phases that we have discussed, these ones have the lowest energy, or let's say least energy. So now you have an idea about what we're calling the Bose-Einstein condensates. We are saying that they are basically very cold solids, and they are at very cold temperatures. Their particles are extremely close together. Because of that, they barely make any movement. And finally, they have the lowest energy among the 5 phases of matter that we have discussed. We can quickly move on to plasma. Plasma is basically hot gas. Or we could say plasma is ionized matter of bare nuclei. Hot gas or ionized matter of bare nuclei. So you can just say plasma is basically hot gas or ionized matter. It exists at very high temperatures, which we cannot really get too close to, like greater than or equal to 3,000 degrees Celsius. So that is quite a high temperature, and that's what we're calling plasma. Because of that, you realize that because the temperature is so high, and one of the assumptions of the kinetic theory is that as temperature increases, the movement of the particles of matter also increase, right? And so if you have something like this, plasma with very high temperature, then we expect that particles will move extremely fast. So the particles of plasma move extremely fast. Now, these particles, as they move, they collide with one another. Another assumption of the kinetic theory, telling us that as the particles move about, they undergo perfectly elastic collisions. Good. So these ones too, the particles collide with one another and they break apart into protons, neutrons, and electrons. So they collide with one another and they split into protons, neutrons, and electrons. And we are saying that this state plasma occurs naturally on the sun and stars. So it's very difficult for us to get so close to the sun. Even we on the earth here, sometimes it becomes so scorchy. See, the sun is so scorchy, you walk through it and you can't bear the heat. So just imagine just going closer to it. So that's what we can learn today about plasma. Basically, it is hot gas or ionized matter. It exists at very high temperature, greater than or equal to 3,000 degrees Celsius. And because of that, its particles move extremely fast. They are fast moving particles, and then they are also far apart and they collide with one another. And we are saying that it occurs naturally on the sun and stars. Let's move on to the ones that we are so familiar with, and we can refresh our memory on these ones. This is our first lesson. In our next lessons, we go on to higher things. So solids have strong intermolecular forces. So our emphasis is on strong intermolecular forces. Strong intermolecular forces. The forces of attraction between the atoms of solids are very strong. And because of that, solids have a rigid or a fixed shape. Just think of a stone. How fixed and how rigid it is. It is because it has got very strong intermolecular forces between its molecules. Now, if you compare solids with liquids and gases, we will say that solids have the strongest intermolecular attraction if you compare the three. Now, solids have a fixed volume. We have established that volume is the space occupied by matter. So the space occupied by solids are fixed. So if you pick a solid in your palm, the space it will occupy, if you take it from your palm and you put it maybe on a table, it will occupy the same measure of space. Then we are saying their molecules are closely arranged. That should not be a surprise, because we have established that the force of attraction between them is very high. Very strong intermolecular force of attraction, pulling the atoms together towards one another. So they are closely arranged. They are closely arranged. As we continue with the properties of solids, their molecules have the least kinetic energy. We are saying that as the molecules move about, the energy they have is kinetic energy. So if they are closely packed and they don't really have the room to really move about, then they will have the least kinetic energy. They will have the least kinetic energy. So they have the least kinetic energy. But then it doesn't mean that the atoms of solids are just static. They vibrate about a fixed mean position. That is something that you should take note of. So they vibrate. If we were to be like human beings, we could say maybe they shiver a little bit. Okay, so you will see them move about briskly to and fro, but they vibrate about a mean fixed position. They don't change their positions from one point to the other as it may happen in other phases of matter, but they vibrate about a fixed mean position. The next thing we want to look at is that solids do not flow. You can't get a solid and then just flowing about with the atoms spreading apart. No, solids do not flow. And then they are not easily compressible. Solids are not easily compressible. That is to say that you can compress some solids, but most often you have to exert a lot of force, a lot of effort into compressing them. So they are not easily compressible. If you compare them with probably the liquids and the gases, solids are not easily compressible. Let's take a step further and look at types of solids. Types of solids. So as we pick solids and try to study about them, looking at their crystal structure, things that we cannot really see with your naked eyes, you would realize that we can get about two types of solids. The first one, crystalline solids. Crystalline solids. And the second one is amorphous solids. Amorphous solids. So we'll take some time and look at the two, crystalline solids and amorphous solids. Let's read the first one, crystalline solids. When we say a solid is a crystalline solid, then we mean the atoms of this solid are arranged in a regular repeating pattern. So the atoms, they're looking at the arrangement of the atoms is regular. So the atoms are arranged in a regular manner, and that manner repeats itself. So you have an atom, so you have atoms of a solid, and these atoms are arranged in a regular repeating manner. Then that solid qualifies to be called a crystalline solid. A crystalline solid. And they have a crystalline structure where the atoms are arranged in that regular repeating pattern called the lattice structure. The lattice structure. So that is it for crystalline solids. We can try and look at probably an illustration of that, how the atoms will look like in their arrangement. How they look like in the arrangement. So let me try and pick up something to represent some atoms. So this, no, I would like to get a different color so that you can see it probably very well. So this, that. So these ones are just trying to represent the atoms of the solid. Then let me say I have these ones to here. So these ones are there and there. Good. So I'll try to get the structure for us. So we have this. Okay. Right. Good. So you can see that this is a regular repeating structure or pattern. So we have the atoms of the solid and they have a regular repeating pattern in their arrangement, like that. So these ones are just representing the atoms of the solid. Good, like that. You can see that there's a pattern. There's a regular arrangement that repeats itself, and that is how it appears for crystalline solids. So we say they have their crystal structure, their lattice structure, showing us a regular repeating arrangement. But then the opposite happens for the amorphous or amorphous solids. They have their atoms arranged in an irregular pattern or manner. Sometimes we call them false solids. So if these ones are false solids, then the first group should be true solids, right? So the crystalline solids will be true solids, and the amorphous solids will become false solids. So they do not have their atoms arranged in a regular repeating pattern. So amorphous solids have their atoms arranged in an irregular pattern or an irregular manner. So we can try and do a little demonstration of how their atoms could look like. You can have this, that. Then I could have this, that, and that. I could have this and that there. Then you get some more. This one here, this one there, this one here, this one there. We try and get their structure. So this takes that and that. See? So with this one, you can't really get a particular pattern or structure repeating itself for the arrangements of the atoms of the solid. Then we say this one is a false solid, and we call them amorphous solids. Amorphous solids. So at least you have learned about two different things now: crystalline solids and amorphous solids. The first group of solids, they have a regular repeating pattern for their crystal structure. The atoms are arranged regularly in a repeated manner. But for amorphous solids, the atoms are not arranged in a regular manner. They are not arranged in a regular repeating manner. So you could find out more about this on the internet. Then we can move on to liquids. Liquids have weaker intermolecular forces than solids. So comparatively, if I compare liquids to solids, then we would say that the force that exists between the molecules of liquids is weaker. It's weaker than that exists between the atoms of solids. So I'll say they have moderate intermolecular force of attraction. In that case, I'm looking at solids, liquids, and gases. So if solids will have the strongest, then liquids, we say you have moderate. You have moderate intermolecular force of attraction. Liquids can flow, and a typical example can be water. Liquids can flow. So if you are not careful and you put a sachet of water somewhere, you're not careful, you just drank some and left some, it will just flow and then maybe get your books wet or some other things wet. And so liquids can flow. Their molecules are not fixed to a point, so they can slide or pass each other within the body of the liquid. So liquids can flow. That's one thing that we can also tell about liquids. Liquids can flow. Now, liquids can take up the shape of their containing vessel. So if you want to get some ice cubes and you want them in rectangular shapes, it means you need to get a container in the shape of a rectangle, and then you pour the water into it and put it in the freezer. It comes out because it comes out as solid ice with that rectangular shape, because the liquid can take the shape of the containing vessel. So liquids can take up the shape of their containing vessel. Liquids do not have a fixed volume. That is one thing we have to take note of. They have a fixed volume. Liquids have a fixed volume. That means that if I pour water on the surface of a table, it will occupy some space. If I pour that same amount of water into a cup, an enclosed place, it should have the same volume. It should occupy the same space. So they have a fixed volume. It is very, very important. Although they have moderate intermolecular force of attraction between their molecules, they have a fixed volume. They are easy to compress as compared to solids. So if you compare liquids to solids, they are easy to compress. Why? They don't really have so much or high forces of attraction between their molecules. So you can easily, or they are quite easy to compress. Now, they have moderate intermolecular spacing. So the space between the molecules of a liquid is a little bit higher than the space between the atoms of a solid. But it cannot be compared with the space between the molecules of a gas. So we are saying that they have moderate intermolecular spacing. They have moderate intermolecular spacing. And because they have that moderate space, then they have moderate intermolecular movements as compared to liquids and gases. So they have the flair to be able to move, change positions a little bit, because they have moderate forces of attraction between their molecules. Now, the molecules have moderate kinetic energy. So I'm just using moderate because I'm comparing that with that of the solid and that of the gas. So their energy with which they move about falls between that of the solids and the gases. So they have moderate kinetic energy. They have moderate kinetic energy. We can move on then to the gases. As we move along, you should be able to be looking at the differences. What is bringing about the major differences between the solids, the liquids, and the gas? Looking at their properties and what is unique to probably each of the phases of matter that we have discussed so far. You should be able to look at those things so that when you are examined, you will do well. So we are looking at the gases. They have the weakest intermolecular forces, and I'm saying they are almost absent. That is to say that if you look at the force of attraction between the molecules of a gas, it's as though there's no force of attraction between them. They have the weakest force of attraction between their molecules. Because of that, their particles are able to move randomly to fill any available space of any container. So you could be at one corner of your room and then you use probably a deodorant spray, and then somebody at the other corner of the room is able to smell your spray from that end. Why? The molecules of the gas are so free. They are so free to move about. So they can move from one place to the other. And they move randomly. They don't really have a particular manner in which they move. So the molecules of a gas undergo random motion. And they exert equal pressure on all surfaces. Wherever they find themselves, they will exert equal pressure on the surface. And because they move randomly about, they are free to move about, they then have the highest kinetic energy. They have the highest kinetic energy. So if you compare kinetic energy of solids, liquids, and gases, the gases have the highest kinetic energy. And it's because they also will have the highest form of movement, or their molecules will have the highest form of movement. You have the highest form of movement. Now, we can move on and say gases have neither fixed shape nor volume. So we spoke about fixed shape and volume for solids, for liquids. Now we are here. We are talking about still fixed shape and volume. But here, we are saying that for gases, they do not have a fixed shape. They do not have a fixed volume, because there is no particular force holding, or strong force holding the molecules together to keep them in that shape, to keep them confined to a particular space. So they don't have a fixed shape. They do not have a fixed volume. And in this case, their molecules are widely spaced. They are widely spaced. So they have the laxity of having spaces between their molecules so they can move about, they can move to and fro. I hope by now you have enjoyed the lesson so far. We've looked at the phases of matter. We've looked at about 5 phases of matter, which you can try and recollect them. And then we looked at the properties of these phases of matter, and we've tried to highlight some differences and some key properties amongst these phases of matter. It is time for us to try and test our understanding and see whether we've been able to really pay particular attention to the lesson and find out if we can answer some few questions correctly. All right, so let us try and get some tutorial exercises to beef our understanding. Okay, now let's look at the first question. It says, with the aid of diagrams, distinguish between solids, liquids, and gases in terms of their molecular arrangement. When you read a question like this, don't be in a hurry to just start answering. You need to ask yourself, what is the meaning of the question? Because what you don't really understand, you can't really give a good response to it. So what is the question asking us to do? The question is saying that we should sit down and analyze how the molecules of these phases of matter, solids, liquids, and gases, are arranged. And then draw a diagram to show the differences between them. So you go and recollect what you've learned so far, that for solids, because they have a very strong intermolecular force of attraction between their atoms, they are closely packed. So you have to draw a diagram and show atoms of a solid that are closely packed. So we can just try our hands on that. So this, I'm going to draw. So these are showing atoms. of the solid. And I'm trying to pack them as much as possible because they should be closely packed. So I can just label solid. Then they say you do that for liquids. So we try for liquids. I'm trying to put down the arrangement of the molecules for liquids. We say for them, they are moderately spaced. They are not too packed like that of solids. So that could be for a liquid. That could be for a liquid. Then we are supposed to do that for gases. Yes, we said that for gases, the molecules are widely spaced. They are widely spaced. They are far apart. So we try and show molecules that are far apart. And they are free to move about. So this will be for gas. So with this, I've tried to answer the question. With the diagrams, I've been able to show the molecular arrangement for the solids, for liquids, and then for gases. I hope your guess was as good as mine. You were able to try it on your own, and that's good. That's good to know. So we can move on to the next question. It says, list 2 pieces of evidence that indicates that there are attractive forces between molecules of matter. Again, we have to look at the question and know what we are asked to do. We have to list 2 pieces of evidence. What do we see around us? What have we experienced that confirms or that shows us that there are attractive forces between molecules of matter? So what have we been able to do to the spaces of matter to change or to increase or to decrease the force of attraction between the molecules? And then what was the consequence? That gives us an evidence that there are forces of attraction between the molecules of matter. So you have to sit quietly and try to think about this. But I have a suggested answer for us. One, I'm saying that solids are more difficult to compress. They are more difficult to compress. Solids are more difficult to compress as compared to liquids. So we are looking at how come I can compress a solid so strongly and then yet I'm not able to compress it. I'm trying to compress, I'm trying to push it together and I'm not able to do it. But I pick a liquid, I try to compress and then I'm able to do it. How come I'm able to do that? Right. And we are saying that solids are more difficult to compress as compared to liquids. It tells me that there is something happening amongst the molecules or the atoms of the solid which is not in that of the liquids. And so it tells me, it's an evidence that there are attractive forces between the molecules of matter. Now, ask yourself, how come I can put a cup of water in the freezer, come back after some hours, and then it's no more liquid, it's now turned into ice, which is solid. So what happened? It means something changed between the attraction of one molecule of water and the other. And that caused it to move from the liquid state into the solid state. So for change of state of water to ice, it is an evidence that matter, or there are attractive forces between the molecules of matter. So change of state of water to ice, or from ice to water, which is vice versa. So if I pick my ice from the freezer, I put it on the table somewhere, with time I see that it starts melting. It starts melting into water. That change of state is an evidence telling me that there are attractive forces between the molecules of matter. And because we have done something to that force, we are seeing a change in the phase of matter. Then the change of water to vapor. So you put some water on fire, and with time it starts to boil, and then the water is turning into vapor. It tells us that indeed there are forces between the molecules, because we have learned that as the temperature increases, the movement of these molecules also increases. Now you have applied heat to the water. It's now boiling. The molecules have gained so much energy. Now they are escaping. Why? Because the force of attraction between them has now become weaker and weaker and weaker. So they are able to move from being just liquids. Now they are turning into gases. So the change of water to vapor is also an evidence that there are attractive forces between the molecules of matter. I am sure you can relate to this and get other examples or other evidence to show that this and that happens because there is attractive forces between the molecules of matter. Let's look at the final question, or let's say the last but one question. It says, what accounts for the main difference between solids, liquids, and gases? What accounts for the main difference? So here too, you need to pay a particular attention to the question. It says main difference. We could write differences between solids, liquids, and gases. Fine. But there is a main difference between solids, liquids, and gases. And what is the reason for this main difference? So what accounts for the main difference between solids, liquids, and gases? So take note of main, and then before the difference. And we are saying that the forces between the molecules brings about the main difference between the gases, the liquids, and the solids. Look at the molecular arrangement. Look at the atomic arrangement of solids and the molecular arrangement of liquids and gases. What brings about one being closely packed, which is the solids, one being moderately packed, which is the liquids, and one having the spaces between the molecules far, far, far apart? It is because of the force of attraction between their molecules. So the force of attraction between the molecules brings or gives us the main difference between the solids, the liquids, and the gases. And then to our final question, we are saying that which of the states of matter has or have definite volume? So we are looking at has or have. That means it could be one or more. So if it is one, the states of matter has. If it is more than one, the states of matter have. So in that case, you are a little bit put in a tight corner here. You could give just only one answer, and the examiner might be looking for two answers or more. So we look through the properties of the solids, the liquids, and the gases, and we find out which of them has or have a definite volume. Try and guess the answer. Let's see. Okay, I am very sure you're able to fish something out, but the answer is solid and liquid. So solids and liquids have definite volume. Solids and liquids have definite volume. That means that no matter where we pick the solid to, no matter how we transfer, where we pick the liquid to, transfer it from maybe a bowl into maybe a plate, into maybe a cup, it will still occupy the same volume. It will still occupy the same volume. I am sure you have enjoyed being with me for a while. We are happy to come to the end of this lesson. I hope to see you another time. So keep doing what you have been doing and be consistent at it, and I'm sure you will succeed. It's bye for now from Pius.
Subscribe to our YouTube channel, Joy Learning TV.